Dear colleagues, let me present the main results of scientific research on the topic, the method of computer modeling of heart rhythm based on the vector of stationary and stationary related random sequences. Nowadays, automated diagnostic systems allow studying the state of the human cardiovascular system. And the effectiveness of such systems depends on their components, including hardware and software tools. Our article discusses a new method of computer modeling of the rhythm of an electrocardiogram signal based on a mathematical model in the form of a vector of stationary correlated random sequences. And generally speaking, this modeling method allows for the information of implementation of the vector rhythm of the cardiac signal for different types of electrocardiogram signals, both in the norm and with various types of rhythm pathologies. Briefly about analysis of known studies. There are many developed automated systems, automated diagnostic systems. For example, known systems that use artificial intelligence and machine learning algorithms are as a result of literature sources number 2 and 3. In literature sources number 4 and 5, you can find information about stochastic mathematical models that have found wide application in some systems. Mathematical models that allow for variability and rhythmic variability are presented in works 6 and 7. New diagnostic features are proposed based on the new mathematical models and methods of rhythm processing, and they are in the literature sources as a result of literature source number 14. And so on. However, rhythm analysis methods have been less widely applied since not all mathematical models take into account the stochasticity and variability of the rhythm. This is due to the insufficient level of development of mathematical models and methods of rhythm analysis, which would allow for the consideration of both the stochastic nature of the signal as manifested in the morphological and rhythmic features of the ECG. So, main results of our research. A rhythmocardiogram signal with increased resolution is substantiated and described using a model in the form of a vector of stationary and stationary related random sequences. Slide number 4. At the same time, more elements of this model can be as elements from a vector, a capital V with index capital L letter. For the case when it's necessary to study the time distances between the same type phases of the electrocardiogram signal in two of its adjacent cycles. We use a mathematical model of the rhythmocardiogram signal with increased resolution in the form expression number 1. To implement the task of modeling of ECG rhythm based on a justified mathematical model in the form of a vector of stationary related random sequences, we consider a special 5-component vector. You can find this expression on the current slide. Durations, this is the vector of duration of the diagnostic zones of the electrocardiogram signal. The model of which is vector key with index 5. Slide number 5. So, figure 1, 1b shows a fragment of the discrete written function obtained using the methods described in the work number 14. And on the current slide, you can see some results of statistical processing of studied data. Figure 2. There are fragments of the implementation of the first and third components of the vector. And figure 3. Here you can see a graphical presentation of implementation, a fragment of the fourth component of the vector, t with index 4, which describes the duration, t, capital T, t's in the electrocardiogram signal. Estimation of correlation functions were determined in our article according to the formula number 2, equation number 2. Here we estimate of mathematical expectations for each of 5 components of our vector, of our studied vector. The obtained results of statistical estimates of the correlation functions are shown in figures 4 and 5. Based on the computer modeling method, modeling experiments were conducted, and the obtained results you can see on the figure 6 and 7. These are the simulated realizations of vector components. Let's perform a statistical evaluation of the model components of the vector and obtain their statistical estimates of correlation functions. The obtained results are presented in figures 8 and 9. Also, we investigated the accuracy of the developed method of computer simulation, and we estimated the errors of computer modeling. To do this, we produced expression number 4. The results of the obtained absolute and relative errors of written modeling are presented in figure number 10, slide number 12. Briefly about analysis of obtained results. Our results suggest that for modeling the written of an electrocardiogram signal based on a model in the form of a vector of stationary related random sequences, the maximum relative error of modeling statistical estimates of vector components doesn't exceed 17%, indicating sufficient accuracy of computer modeling. And generally speaking, in our article we showed that this diagnostic complex includes an additional block for computer modeling of a vector cardiogram signal, stationary related random sequences. Conclusion, you can see on the slide number 14. So, in further studies, it's planned to process ECGs realizations with various types of written pathologies such as tachycardia, bradycardia, arrhythmia, and so on. Thank you very much for your attention.